Section 1.2, we're going to talk about graphing linear equations. Alright, we need a few definitions before we get into this. First is a linear equation. A linear equation is any equation that can be written in this form: ax plus by equals c, where a, b, and c are real numbers. Now, basically, what we look for a linear equation, we look for that it has variables. In this case, we have x and y, and the power on the variable is just a 1. So, let me give you some examples of things that are linear and things that are not linear. So let's do linear first. So linear might look like 2x minus 3y equals 8. There's a linear equation. Notice it has ax, a is the number 2, by, b is the number -3, and c. Okay. Now, for most of the equations that we're going to deal with, we won't write them in this form. Quite often we're going to see them in this form, maybe y equals 2x minus 5. So again, we recognize this as linear. It doesn't fit into the form of the definition, but we notice that we have a y, and there's no power on the y. Well, there's a 1, we don't write it. And then we have an x somewhere showing up, and there's a power of 1 on the x. Okay, now there are a couple specialty kind of lines that we'll look at here in a few minutes, such as x equals 2. And the way that this fits into this form is a is the number 1, so we have 1 times x. B would be the number 0. 0 times y would be 0, so the y disappears, equals 2. And that's a special kind of line. We'll look at that in a few minutes. Similarly, you could have y equals 4. Kind of the same trick. A is a number 0, b is a number 1, c is a number 4. Alright, what we're going to do with these linear equations is we're going to graph them. Oh, let me give you some of the things that are nonlinear first. I said I would do some nonlinear. Nonlinear would look something like y equals x squared. So notice this is nonlinear because it has a power right there. It has an x squared. You can't have powers. Another nonlinear thing would be y equals 3 over x. We're not allowed to have the x in the bottom. The x is supposed to be up in the top. Now we can have fractions. Don't get me wrong. We could have something like y equals 1/2 x minus 3. That would still be linear because the x is not in the bottom. Alright, one more nonlinear thing. Y equals square root of x. We can't have square roots. Okay, so what we're going to do is we're going to talk about graphs. And the graph of an equation is the set of all points that satisfy the equation. Now, that sounds fancy. Really isn't. So let me show you what I mean. Let's say we have the equation y equals 2x minus 3. There are actually many ways to graph a line. What we're going to do in this section is we're going to do pretty much the most basic method. And the most basic method is we pick some points for x and we plug them in. There's really no set rule on what numbers you can plug in. My general rule of thumb is I always like to plug in 0. And then I like to plug in a couple positive numbers. I'm going to plug in 1 and 3. And I like to plug in a couple of negative numbers. -2 and -5. And again, there's really no rule on that. A lot of students will just say, well, can I use 0, 1, and 2, and -1 and -2? And the answer is yes. Absolutely you can. Plug pretty much any numbers you want. Alright, so when I plug 0 in, plug 0 in here. 2 times 0 is 0. 0 minus 3 is -3. Plug 1 in. 2 times 1 is 2. 2 minus 3 is -1. Plug 3 in. 3 times 2 is 6. 6 minus 3 is 3. Plug in -2. 2 times -2 is -4. Negative 4 minus 3 is negative 7. And finally, I plug negative 5 in. 2 times negative 5 is negative 10. Negative 10 minus 3 is negative 13. Okay, now I'm going to go over here and I'm going to graph. Now what I need to do to graph, you need to have the axes. The axes are drawn here. And then you need to have what's known as scaling. Scaling can be done any way you want. Traditionally, if your numbers are fairly small, like our numbers are here, we would just go by ones. But you do have to indicate it. So I would go, you don't have to mark every little number. In this case, I'm going to go 2, 4, 6. And negative 2, negative 4, negative 6. I'm going to mark enough just to indicate so that somebody reading the graph knows what the scaling is. A graph without any scaling really doesn't make any sense. There we go. Now we mark. And hopefully you remember how to graph points like this. X is the left and right, and Y is the up and down. So X being 0 means I start right at the origin, and Y being negative 3 means I go down 3 from there. 0, negative 3 is right there. 1, negative 1, I start at the origin, which is here. 1 to the right, negative 1 down. It's right there. 3, 3. Again, I start at the origin. X is 3, so I go 3 to the right. Y is 3, I go 3 up. Mark my point there. Negative 2, negative 7. Negative 2 to the left, and then 7 down is right there. And finally, negative 5, negative 13. All right, this wasn't a real good choice because it kind of goes off my grid, but it's got to be right there. And the reason I think it's got to be right there is, of course, this is a linear function. And the reason we call them linear is when we graph them, we get a nice straight line. All right, let's take a look at this next problem. Y equals 1/3 x plus 2. Same idea. We want to plug in 0, plug in a couple positive numbers, plug in a couple negative numbers. Plug in 0. 1/3 times 0 is 0. 0 plus 2 is 2. Now, we need to be clever with this one. And what I mean by clever is it's not very clever to just plug in 0, 1, and 2. Because what happens when I plug in 1, 1/3 times 1 is 1/3. 1/3 plus 2 is 2 1/3. And, you know, there's nothing wrong with 2 1/3, but it makes it difficult to graph. 2 1/3, I kind of got to estimate. I don't like that very much. Same if I plug in 2. If I plug in 2, I get 1/3 times 2 is 2/3. 2 plus 2/3 is 2 1/3. 2 2/3. So what we want to do is we want to be clever. We want to plug in numbers that are going to make this 3 reduce. In other words, what we want to plug in is we want to plug in multiples of 3. So again, nothing wrong with these numbers, but I'm not going to use them because I don't like the fractions. If I plug in 3, 1/3 times 3 plus 2, think of 3 as being 3 over 1. 1/3 times 3, the 3's reduce, and you get 1. 1 plus 2 is 3. A nice number to graph, and that's what we want to use. The next multiple of 3 would be the number 6. So that's the next number I would plug in. 1/3 times 6 plus 2. Again, think of 6 as being 6 over 1. Reduce. You get 2 plus 2. That's 4. And for my negative numbers, I'm going to use negative 3 and negative 6. So when this first number here is a fraction, you want to be a little bit more clever. Don't just go 0, 1, 2. Plug in numbers that are going to help you reduce this fraction. All right, 1/3 times negative 3 plus 2. Again, I can reduce. That reduces to negative 1. Negative 2 plus 1 is 1. And finally, when I plug in negative 6, 1/3 times negative 6 plus 2, those reduce to be a negative 2. Negative 2 plus 2 is 0. Okay, so now we have nice numbers. We avoided the fractions. That's being clever. 0, 2 is right there. 1, 2. 3, 3, 6, 4. Now, there may be times in the future when we have to deal with fractions. And when that happens, we will. But if we can avoid them as much as possible, we do. Now, notice I turned off the video and I pre-scaled my axes. Again, when you go to draw your answers, you do need to scale your axes. If you don't, you're going to lose partial credit. Graph with no scale doesn't make any sense. And there's our nice straight line. All right, one more of these. How about y equals minus 1/5 x minus 2. Again, I'm going to plug in my numbers. I'm going to plug in 0. When I plug in 0, I get negative 2. Then, I look at my denominator. My denominator has a 5 on bottom, so the clever numbers to plug in are 5 and 10, because those are multiples of 5. And then negative 5 and negative 10. Plug in 5. I have negative 1/5 times 5. That's negative 1. Negative 1 minus 2 is negative 3. Plug in 10. Negative 1/5 times 10 is negative 2. Negative 2 minus 2 is negative 4. Plug in negative 5. I have negative 1/5 times negative 5. That's 1. 1 minus 2 is negative 1. And finally, when I plug in negative 10 times negative 1/5 is 2. 2 minus 2, 0. Alright, so this time I'm going to scale my axes. I'm just going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on the x-axis, because those are the numbers I need to use. And on my y-axis, I'll mark 2 and 4 again. Negative 2 and negative 4. Alright, 0, negative 2, right there. 5, negative 3. 1, 2, 3. 10, negative 4. Negative 5, negative 1. And negative 10, 0. Once again, I play a game of connect the dots. I'm all done. Okay, once again, I want you to pause the video at this point and try problems 3 and 4 and see how those go.